Let's look at the next objective, 1 Delta, identify basic facts about principles, capabilities, limitations of multiplexing equipment. This will be about the NSM 50. Just remember, you gotta get 70% on the block test. That means you have to get 28 of them correct. AFSC application, because you will be working on a multiplexer when you get to block 9, as well as doing the labs here in the NSM for block 7. We're going to be looking at the NSM, and I'm going to quickly go through it because I'm more interested in getting to the tech manual to show you everything that the slideshow is giving us. We're going to look at the Vertex, which is the main brand for it, Nodal Satellite Multiplexer, NSM 50. Purpose, what we're going to look at, functional description, operational characteristics, and NSM configuration. What does the NSM do? Multiplexes and demultiplexes. If it does it in multiplex, it has to do it in demultiplex, like I explained to you back in Objective 1 Alpha when we were going through the FCC 100. If you got an encryption to multiplex it, you're going to have the encryption on demultiplex, so forth and so on. The max data rate for the NSM is 52 megabits per second. Has 2 operational modes, and there's a couple places in there you got to figure out which one of those operational modes that they're referencing. Ours is legacy and enhance. There's actually 3 modes when you are firing it up. 2 modes when we're talking about the data. Again, legacy and enhance, you can select this on the NSM program. There are 4 ports. You got the 12 NRZ ports, 4 different types of ports. We got 12 NRZ, 6 T1E1s, 6 CDI, and 2 high-speed serial interface. This is what it looks like. Remember I told you about the D connectors? Well, this is what you're connecting to. This is on the back of the case. If you take a look at above me, you can see the 3 cases. This is the farthest one on the left-hand side. On the back of it, this is what you will see. For those of you that haven't been looking at it yet, and that's the Senior, Quiznos, and Bell. We're going to refer to this extract here in just a few minutes. I just wanted to get through it just to show you that, hey, we're going to be going through it here in just a few minutes. And again, this is a summary, purpose, description, operational characteristics, configuration. But first, we are going to hit the HST 3000. Now, with this one, 2 Alpha says identify basic facts, capabilities, and limitations from the bit error rate test set, BERTS, not Bert and Ernie, but BERTS. And we're going to be looking at the HST 3000. Again, 70% on the test. Application, there is a very good chance that if you're working on SATCOM gear, you're going to have access to a bit error rate test set. Now, why do we have the HST 3000? That's because that's the piece of equipment we got. If you were to go out on eBay, you can buy this brand new for about $3,000. This is a lot of money. Yeah, really. This is an older model now because when we got it, it was brand new. But it's one of those, if it ain't broke, don't fix it. Is it possible we may get some in the near future? It's always possible. HST 3000s, it's a newer model. I think it's an HST 5000. It's just like with any other electronic devices out there. Look at TVs. Back in the day, they were all tube TVs. Then it came to just the CRT. Everything went to solid state in the electronics. Now what is it? Well, it's nothing more than an LCD or plasma if you can find one. I don't think you can find one anymore, can you? Now they've gone to quantum dots or red, green, blue, yellow LEDs. So you can see how technology has progressed. The HST 3000 does wonderful for us. Again, if it ain't broke, don't fix it. What does a basic BERTS do for us? Well, you're looking at testing and loopbacks. The idea behind it is to check the signal. When we are going, that bottom line there, alone or alongside traffic. Remember I told you about a DTE being the terminal, the source, and the destination? Well, in HST 3000, you're going to enter in the data rate. The way it travels is it's going to send it out to the NSM. The NSM is going to be in a loop back, and it's going to come out to the HST 3000 to be that DTE. Now, the other part where it says along mission traffic, that's the monitor portion where you're going to see if it has any errors on the transmission of that data. That's what a BERTS does. It looks at it. You can either simulate it as the computer, or you can take a look at the traffic without impeding anything. Mission traffic being the aggregate that's being sent out from point A to point B. Let's look at the 3000 itself. It's rugged, handheld, battery operated. Yeah, you can disconnect it. We do have end-to-end testing and bit error rate testing. That's basically your long side or your end-to-end, which is the DTE. There are 3 test modes that you can put the HST 3000 in. DT emulation, like we discussed earlier. DC emulation, which we can make it look like the modem. And the monitor, which is the bit error rate portion. That was pretty much it. Now, when you're looking at the test, again, the HST 3000 all comes from the Study Guide workbook because the manual is very small, so we just took out what was needed and just gave you an overview of what a BERTS does and what the HST 3000 does. Let's take a look at this. So everybody pull up their operator's instruction manual for the NSM, or go in your files and you should see, and this is all the downloaded stuff that you should have. It's the 31 Romeo 2-2 Tango Sierra Charlie 179. Should say extract NSM 50 operator's manual in a PDF file. I'll wait till you get it up and operational. Give me a thumbs up when you finally get it up online so we can go through it.
My thumbs up.
Mine as well.
My pinky's up.
He said thumb.
Alright, now my thumbs up.
There you go.
Stevens? Good?
Steering.
Hello?
I can hear you. You got it up and operational?
Well said.
Whereas you got yours good?
The live stream?
No, we're talking the NSM tech manual. The reason why I ask you to pull it up is so you can highlight some of the things that I have in here for future reference. Now, you can't take this into the test with you, but it gives you an idea how to look for this stuff. All right, so let's take a look. How about this? There we go. Okay, this is the introduction. This is where it comes with the Vertex RSI. That is the brand of the company. It is a nodal satellite multiplexer, different than what's above me, which is an iDirect modem. It is compact, lightweight, synchronous, Where have you heard that from? Time division multiplexer that provides both aggregate interfaces to satellite modems. Again, above me, the iDirect is a modem. And group interfaces to ground equipment, which is the 3 cases above it. Functional description. Okay, this gives you an idea what the multiplexer does as far as multiplexing and demultiplexing. You'll notice there is what we call M mic, and then I don't even know what that sign is. I'm not even going to go. I always call it the and symbol, and then Charlie. That is what you're going to be looking at when you select on the program as far as inputting everything. It says the operator to select port line interface types, configure port rates and aggregate setup, control user port aggregate loopbacks. That's what you guys have been doing on that cut sheet. And monitor the status of the NSM alarms and diagnostics. That's when you got everything programmed to include the HST 3000 and you're doing the loop back. Do you get the alarm? Do you get any alarms on the information? That's what it's looking for. So you can look at 10 status LEDs on the front panel. Now, again, above me, you can see the 3 cases. Off to the left is the NSM. It is the top piece. It's not very big. All the LEDs are on the front panel. There's nothing on the back panel. I already showed you what's on the back panel. This gives you an idea of what we've gone over. Signals between NSM and the control computer, because that's what it is. On the case itself is the control computer. Looks like it goes between an RS-232 and an RS-422 DTE signals. DTE. So the computer is acting like a terminal, and so forth and so on. I just highlighted these to give you an idea. So let's look at 1.3.1.5 external signal interface descriptions, better known as Bravo. To start with, we have NRZ, that's our signal format. Group port data must be a balanced RS-422. What does it mean by a balanced line, Thomas?
Balance means that it's twisted cable, twisted pair.
And
oh wait, I'm not sure what else you're asking.
okay, anybody? What else has to come up?
Oh wait,
That's 180.
Go ahead, Mills. I
Wait.
couldn't hear you.
I just said that it has 2 wires. That one is 180 degrees out.
That's the key part there. 180 degrees out. Good. So we look at the 2 modes like we discussed earlier in the slideshow, legacy and enhanced. So here's a question for you. Let's ask Marshman. What is the max data rate for the NRZ group port?
The max data rate
Mm-hmm.
is it 8,448 kilobits per second?
Now, how did you figure that out?
I read on the enhanced mode, it says from 8 kilobits per second up to and including 8,448.
Why couldn't you use the legacy mode?
I'm not sure.
Go with your gut instinct.
My gut instinct's drawing a blank. It's letting me down right now.
Okay. All right. Let me see if I can't clarify that. All right. When I asked for a max data rate on the NRZ group port, you looked at legacy and you saw the highest number in there was 1152K. Right?
Yes, sir.
And then you looked at enhance and went, wait a minute, 844.8K is much higher than 1152, isn't it?
Yes, sir.
There you go. Common sense just came into fruition there. All right. So,
I see.
yeah. What's the difference between legacy and enhance? Anybody?
Legacy is using like older equipment along with it.
Bingo. Enhance being the newer equipment. Good. That is excellent. First time that anybody's got that question right in a very long time.
So what if you use legacy mode on new equipment? Will it not run properly?
It probably will not. Now let me explain. Okay. The reason why they have legacy and enhanced is you don't know what the distant end has until you get out there. When you, hopefully you know before you leave, but sometimes that's not the case. Okay, so going from one base to another, many thousands of miles apart, hopefully, their equipment and your equipment matches. There will be a very good chance that some of the older bases are going to have the legacy equipment, and the newer bases will have the enhanced equipment. At least you hope. But with this particular equipment, they cover both bases with that. That way, when you take it out there, it's very flexible to reprogram your stuff to where it works. For example, and I can think of one instance where the base that I was at, their SATCOM people were freaking out, and all they had to do was go to a legacy mode because of their older equipment and tell the distant end, hey, I've gone to an older piece of equipment because the newer one broke. So you see how that scenario fits into play?
Yes, sir. I see the scenario.
Okay, so it just depends on what's out there, and we may have to mix and match different pieces of equipment, and this equipment is very flexible at it. So let's take a look at Charlie, the T1E1 groups. Okay, this is bipolar. Okay, we've gone over that signal format, haven't we? We look at number 1, T1. Well, that's hierarchy, isn't it? Sure is. Sure is. AMI. Thomas, what does AMI mean?
I know it means two separate things. I remember that you're talking about it. I forget what they both are, though.
Anybody? No one remembers. Alternate mark inversion. It's the same thing.
That's also RZ polar?
Bipolar.
Bipolar, okay.
Yes. Alternate mark meaning if it's a 1, it's going to go to the +5, and the next one, logic 1, should go to a -5. Now you'll notice it says 8, Bravo 8, Zulu Sierra. That's out. Bipolar with 0 suppression. The 8 tells us it is throwing the 0 at the 8th 0. That's the bit violation. And my handy dandy note tells me that it is North American. North American. Let's look at number 2. It says E1. AMI, alternate mark inversion, Hotel Delta Bravo 3. Remember I told you about that one? That's Europe or Japan. This one throws it at the 4th 0. So you can see that if I plug either one of those in there, it's going to either be a T1 line to North America, or it's going to be an E1 line, which is, from what I gather, it is a T1 line in our instance, but it's either in Europe or Japan. So you can see that this particular one can link up with our allies overseas. See how flexible it is? Let's look at Delta. CDI. Holy crap. Stevens. What makes CDI so much more different than all those other signal formats?
Hello?
Yeah, I can hear you.
What makes it different from the other formats
Mm-hmm.
is,
Phone a friend?
it's, the transition is in phase or out of phase.
Yes, one word, transitions. That's what makes it so much different.
Wait, I'm sorry, what was the question?
Okay, the question is what makes CDI so much more different than the other signal formats? You remember that this morning?
Transitions?
Yeah, transitions.
Okay.
Yeah, because transitions does. Because with a logic of 1, it doesn't care if it's at the 0 or the 5. All it does is one transition. If it's a logic level of 0, again, it doesn't care if it starts at the 0 or the +5. It does 2 transitions in there. That's the difference. And again, it has legacy and enhanced mode. Let's go to the next one, which is echo. This one, we just went over an EIA 530. That must be pretty doggone fast. And EIA 613. Looks like it increased, didn't it? HISI, high-speed serial interface. It has 2 enhanced modes. If you're using the 530, you can only go up to 24 meg. If you're using the enhanced 613, it's all the way up to 52 megahertz, or megabits per second. Sorry about that. So you can see how everything that we've gone over in the last couple days, well actually Friday and today, in how it applies to the NSM Tech Manual. We haven't led you astray here. We've led you down this straight and narrow path to get you to understand what's in that manual. Oh, look at this. Foxtrot. Secure order wire data signals must be unbalanced NRZ. Thomas, tell me everything you know about unbalanced.
Unbalanced coaxial. Correct?
Mm-hmm.
And it uses those wires around that center conductor to reduce interference.
And how does it do that?
Is that I'm trying to remember, sir.
Fine.
It's crowded, sir. Doing that all on my own.
That's pretty good, guys.
Good job, Thomas.
Thank you, Thomas.
The voices are talking to you.
Yeah, I got voices in my head, sir, so.
And we can hear them.
Oh, you guys can hear them too? I thought I was alone.
So you can see that everything we've gone over in the last, 2 days there it's playing into this NSM Tech Manual. And it just really weird, isn't it, how we're able to do that and explain everything in here. So let's keep going. That's the tough book that you guys are playing with, and of course it just tells you everything you need to know about it. I'm not too concerned about it. When you look at the purpose of equipment, from the slideshow to here, it pretty much is similar. But one thing I wanted to show on this is figure 2-1 multiplexer operation. This gives you an overview of everything in a general picture. Data streams. Those are your user. It goes into the NSM, gets multiplex, sends it to the iDirect modem. The modem sends that information to the satellite system, and it uplinks it to the bird in the sky. That bird in the sky relays it back down to another satellite system thousands of miles away. modulates it. Yeah, demodulation. And then it gets into the NSM50, which demultiplexes it into the users that need it. That is the scenario that's played out here. I love this picture. Functional operation. This one had some people confused, and this is the reason why I highlighted it, is people didn't understand the words mux and demux. Well, mux mean multiplexing or modulate. Demux meaning it's demultiplexing or demodulating. And when we get into the modems and how they are utilized as far as getting their modulation on, so to speak, you're going to see that. Again, I'm all about the pictures. Look at this port router. You can see the ports and how everything works as far as how many go to which one. So there's 12 NRZ, 2 HISI, 6 T1E1s, and 6 CDI, excuse me. And I remember someone saying about the mesh. There you go. I love this particular one, 2.3.1 network configurations, because it's very simple in explanation of what a point-to-point, a hub spoke, a mesh, or a hybrid is. Modes of operation, you can see this is where you can put it in 3 different operations, as opposed to what operations are you going to work with the ports. So you got legacy and enhance versus the inactive mode, the preliminary mode, and operate mode. These are, the when you fire it up or when nothing's working and so forth and so on. Not to be confused. Now, this one, 2.3.3 user port interfaces, it just goes to show you another place in the tech manual where you can look up how many of these things are. Okay? And I think this is it. Timing modes. I'm not sure if you've ever pulled up how does a multiplexer work? Most of the time when I do that, I end up getting professors. There's very few out there that can relay the information without being what I call oversaturation with technical jargon that I don't understand. There is one that after about the first minute or two went, oh, no kidding, this is how it works. The bottom line is a multiplexer is nothing more than a switch going from one channel to the next channel to the next channel and then back around again. So it's a constant, 360 degrees around all the channels until it gets back to channel 1. That's all it is. It's a big switch. Now, it does have timing in there. It does have references on which one to do when. Order wire. We are going to see that a lot. This is your first introduction to order wire, but we're going to get to it in deep when we get to the Jerk 239. That's the TISR. What is order wire? Order wire is the maintenance's ability to be able to talk with each other from point A to point B and trying to figure out if there's something wrong with their equipment, whether it's a user or if it's a big piece of equipment. It's our own little channel. You're going to see it in the TISR. This is the rear of the NSM50, and you're going, no, it's not. Yeah, it is. Okay, realistically, the NSM50 is not that big. What you see on the front panel is just the front. It's probably maybe a foot long, but what you don't see is the inside of it or the back of it. Now, let me explain this. If you take a look at Juliet 2 and Juliet 3, you will see NRZ 1 through 6 and NRZ 6 through 12. what that is telling you is you are connecting ports 1 through 6 on a single input-output. You see off to the right there where it says high density DB62 socket. What that's telling you is coming out of that NSM, it's going to take the place, there's going to be 6 different cable pieces. It's going to be paralleled and go into the rear of that case, and that's where you see the breakup on the back of the case. Remember we talked about DB connectors? Underneath that DB62 socket, you can see we have a DB25 socket. Underneath the hissy one, you see a DB9 socket, and so forth and so on. So you see where the DBs come into play. Why do they call it DB? Because it looks like a D connector. This is the front panel that you see. Not very big. You can see that 1 through 8 shows you everything you need to know. Just remember number 5 is the error light. If the error light is illuminating, you got some problems with it. Some of the things that I see a problem with is you guys will go ahead and put everything in, and the light will be green until the HST 3000 send one of the wrong data rates, and all of a sudden it will turn red, and then your alarms on your computer will go red. Normally it's about 10-15 seconds after you go, haha, I got it all right, yay, and then it goes, oops. Normally it's a mistake on a data rate or where you put it in at. So it just goes to show you, hey, you know, we're out there. This looks familiar to you if you keep scrolling through. And I think that's all of it that I had. Yeah, that's it. So with that in mind, we have gone through 1 alpha through 1 bravo homework. We've gone through 1 Charlie, 1 Delta, and 2 Alpha as far as our objectives today. Any questions? Questions? Good to go? All right, so here's what's going to happen. Tomorrow at 12:30, let's back up one. I have SIA between 10 and 11. Tomorrow at 12:30 is class. Homework for 1 Charlie through 2 Alpha will be due. After class, turn all of it into me so I can take a look at it. Any questions on what we're doing tomorrow as far as homework?
No, sir.
Okay, so the next step would be we're going to be covering 3 Alpha, Bravo, and I think 4 Alpha. There is an outside possibility I might have to attend a meeting tomorrow, so I may end up cutting it short if they request me, and we'll go from there.